Today's lesson is about properties of triangles, and we're looking specifically at perpendiculars and bisectors. The perpendicular bisector of a segment is a segment line, ray, or etc., that is perpendicular to a segment at its midpoint. So, for instance, here we have a segment AE, and C is the midpoint, and line DB is perpendicular to it. So we will say that DB, because it goes through the midpoint, is the perpendicular bisector. Of segment AE. Now, when we come to class, I am going to show you how to do the construction of a perpendicular through a point on a line, and we will be doing that in class. So let's move on to the next page. Here we have theorem 5.1, which deals with perpendicular bisectors. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. So, for instance, what I've drawn here is here's the segment. Let's call it AX. Here is the midpoint of the segment. We'll call it T. And ZT is the perpendicular bisector of that. So AT is congruent to TX. And what this means is that point Z, which is on the perpendicular bisector of the segment, must be equidistant from the endpoints of the segment. So if I were to draw lines from Z to A and Z to X, they would have to be equal in length. That's what equidistant means, equal in length. Next one. Theorem 5.2 is converse of the perpendicular bisector. It says if a point is equidistant from the endpoints of a segment. So here you have this point, let's call it X. It's equidistant from these 2 points, M and P. So it's the same distance. Then the point lies on the perpendicular bisector of the segment. So this line here must be the perpendicular bisector. Let's call this point O. So we'll say XO is the, I'm going to abbreviate this, perpendicular bisector of MP. Moving on. Let's say that we are looking at this particular diagram. If we want to talk about the distance between a point and a line, it's the perpendicular distance. So if we wanted to look at the distance between, say, this point here and this particular line, it would be this perpendicular distance here. So if I'm asking you for the distance between a point and a line, imagine a perpendicular segment drawn to that line, and that is the distance that we're talking about. So next, theorem 5.3, angle bisector. If a point is on the bisector of an angle, then it is equidistant from the sides of the angle. So here you have this angle. Here we have this perpendicular bisector here. It's cutting this angle into 2 smaller equal angles. And here's the point on the bisector of the angle. Now remember, we just said distance is the perpendicular distance to the line. So these lines are forming right angles. And what we're saying is those perpendicular segments are of the same length. They're equidistant. So if this point is on the angle bisector, then these segments are equal in length if they are drawn perpendicularly to the sides of the angle. Let's move on to the next page. Theorem 5.4 is the converse of the angle bisector. If a point is equidistant from the sides of an angle, so here's our point, and we've got these lines that are drawn perpendicularly to the sides of the angle, and they're the same length, we can conclude that this point must be on the bisector of this angle. So if we want to label some points here, let's say X, O, W, P, we can say that PO is the angle bisector of angle XOW. So next, moving on. Properties of triangles. We're looking at bisectors of triangles now. And first of all, we need to look at the definition of concurrent lines. Three or more lines that intersect at the same point are called concurrent lines. And the point where they intersect is the point of concurrency. What I'm highlighting in red here is the point of concurrency. So if they intersect at the same point, they're concurrent lines. That's an expression we'll be using. Perpendicular bisector of a triangle is a line, ray, etc. that is perpendicular to one side of a triangle at its midpoint. So here's the midpoint of this triangle. So it breaks it up into two equal sections on that side. And this line, to be the perpendicular of the bisector, has to be perpendicular to that side and has to go through that midpoint. So this line is the perpendicular bisector. The circumcenter, so this is just a lot of vocabulary today with diagrams, is the point of concurrency of the three perpendicular bisectors of a triangle. So in the blue, here are your perpendicular bisectors, the blue lines. There are three sides to a triangle, so there are three perpendicular bisectors. Notice they all form right angles with the sides, and they go through the midpoints of each side of the triangle. Notice all three of those lines meet at one point, which we call the circumcenter. That is the circumcenter. Now, I've also drawn some other lines here. That circumcenter is equidistant from the three vertices. So I've drawn a line from that circumcenter out to the three vertices. All of those black lines there are the same length. And if you were to circumscribe a circle from that center, it would touch the vertices of that triangle. So that's kind of neat. Moving on. The angle bisector of a triangle is a segment or ray that bisects one angle of a triangle. It makes it into two smaller equal angles. So maybe what I should have been more careful saying is, here is an example of an angle bisector. Angle bisector bisects the angle and makes two smaller equal angles. Same thing occurs in a triangle, you can imagine. This is the angle bisector of a triangle. So you can imagine one angle that's bisected. Very similar. But you can do this with all three angles in a triangle. And here's a picture of what that looks like. The blue lines show all of the angle bisectors of a triangle. And where they intersect is called the incenter. And that is the point of concurrency of the three angle bisectors of a triangle. And some neat things about it. The incenter is equidistant from the sides of the triangle. So if you were to have perpendicular bisectors go from the incenter to the sides of the triangle, they would be the same length. And also notice that if you take a circle and inscribe it in this triangle, it will give you this resulting picture. So this was just a whole lot of vocabulary today that we've learned and some diagrams. We're going to be going over constructions in class. I'm sure you've noticed that here I've written Sketchpad. I'm going to show you how to create the angle bisectors of a triangle through constructions, and we'll be doing that in class. Bring your questions with you. Thank you.